In our learning goal, we'll be dealing with the real number system. Remember, natural numbers are our counting numbers, 1, 2, 3, 4, 5, and so on. Whole numbers are our natural numbers plus the number 0. Those numbers go 0, 1, 2, 3, 4, and so on. Integers are all our whole numbers, all our natural numbers, and the negations. But remember, negative 0 is just 0. Rational numbers, also known as fractions, any number that can be written in the form of a over b, where a and b are integers and b does not equal 0. This also includes repeating decimals and terminating decimals. The real number system, everything in this green oval, natural numbers, whole numbers, integers, rational, and then the other set of irrational, are all types of real numbers. Notice that natural numbers are inside the group of whole numbers. Whole numbers and natural numbers are inside the group of integers. Natural numbers, whole numbers, and integers are inside the group of rational numbers. And natural numbers, whole numbers, integers, and rationals are all inside the group of real numbers. Outside the group of rationals are irrationals, but irrationals are also inside the group of real numbers. If you are a real number, you could only be irrational or rational. You cannot be both. Rational numbers can be written as a ratio. Terminating decimals such as 0.45 or repeating decimals such as 0.7777 are also numbers that can be written as ratios. Real numbers are either rational or irrational. A number cannot be both rational and irrational. In our lesson for today, we'll be adding and subtracting rational numbers. By the end of this lesson, I'll be able to add rational numbers, fractions with unlike denominators. How does knowing your math facts help you in reducing fractions and in finding the GCF and LCM of two numbers? In our last lesson, we learned we can add or subtract fractions with the same denominator. Fractions with the same denominator are called like fractions. Step 1. Rewrite fractions with the same denominator by finding the LCM. Step 2. Add numerators only. Step 3. Reduce fractions to simplest form. 5/8 plus 1/6. We'll take our denominators of 8 and 6 and find the LCM. What number goes into both 8 and 6 evenly? And that would be 2. 8 divided by 2 is 4, 6 divided by 2 is 3. Since 4 and 3 are relatively prime, we stop. 4 times 6 is 24, as well as 3 times 8 is 24. So now we know the fraction with a denominator of 8 will multiply the top and bottom by 3, and the fraction with a denominator of 6 will multiply the top and bottom by 4, like so. 3 times 5 is 15, plus 1 times 4, which is 4. We're going to write that all over 24, because 3 times 8 was 24, and 6 times 4 was 24. 5 plus 4 is 19, and since 19 and 24 are relatively prime, we are finished. 5 twelfths plus 4 ninths. We'll take our denominators and find the LCM. What number goes into both 12 and 9? And that would be 3. 12 divided by 3 is 4, 9 divided by 3 is 3. Since 4 and 3 are relatively prime, we can multiply the 9 by 4 and the 3 by 12, which is 36. So now we know the fraction with a denominator of 12 will multiply the top and bottom by 3, and the fraction with a denominator of 9 will multiply the top and bottom by 4. 3 times 5 is 15, plus 4 times 4, which is 16, all over 36. 15 plus 16 is 31. Since they're relatively prime, the numerator and denominator, we are finished. 7/16 plus 4/10. We'll take our denominators and find the LCM. What number goes into both 16 and 10 evenly? And that would be 2. 16 divided by 2 is 8. 10 divided by 2 is 5. Since 8 and 5 are relatively prime, we can multiply the 5 times 16 and the 8 times 10, which is 80. The fraction with a denominator of 16 will multiply the top and bottom by 5, and the fraction with a denominator of 10 will multiply the top and bottom by 8. 5 times 7 is 35, plus 4 times 8, which is 32, all over 80. 35 plus 32 is 67. Since 67 and 80 are relatively prime, it's in simplest form. 11/18 minus 5/12. We'll take the 18 and the 12 and find the LCM. What number goes into 18 and 12 evenly? If you said 2, you are correct. If you said 3, you are correct. But the greatest common factor would be 6. 18 divided by 6 is 3. 12 divided by 6 is 2. Since 3 and 2 are relatively prime, we can multiply 3 times 12 and 2 times 18, which both give us 36. Therefore, the fraction with a denominator of 18 will multiply the top and bottom by 2, and the fraction with a denominator of 12 will multiply the top and bottom by 3. 2 times 11 is 22, minus 5 times 3, which is 15, all over 36. 22 minus 15 is 7 over 36. Since 7 and 36 are relatively prime, we know we have a fraction in simplest form. 5/12 minus 7/9. We'll take the 12 and the 9 and we'll find the LCM. What number goes into both 12 and 9 evenly? And that would be 3. 12 divided by 3 is 4. 9 divided by 3 is 3. Since 4 and 3 are relatively prime, we can multiply 4 times 9 as well as 3 times 12. The result is 36. Fraction with the denominator of 12 will multiply the top and bottom by 3, and the fraction with the denominator of 9 will multiply the top and bottom by 4. 3 times 5 is 15, minus 7 times 4, which is 28, all over 36. 15 minus 28, we may want to use a T-chart. 15 is positive, so we'll place it on the positive side. 28, since it's a minus in front, it will be considered negative. Remember, if they're on different sides, we move the smaller one over and subtract. 8 minus 5 is 3. 2 minus 1 is 1. Since it's underneath the negative sign, we know it's going to be a negative 13. 15 minus 28 is negative 13, all over 36. And we know that 13 and 36 are relatively prime, so we are finished. In making baked ziti, Alonzo used 4/15 of a cup of mozzarella cheese and 5/12 of a cup of Parmesan cheese. How much cheese did Alonzo use in all? In this problem, we'll find the sum. 4/15 plus 5/12. We'll have to find the LCM of 15 and 12. What number goes into 15 and 12 evenly? And that would be 3. 15 divided by 3 is 5, and 12 divided by 3 is 4. Since 5 and 4 are relatively prime, we know our GCF is 3. We can multiply 4 times 15. Therefore, the fraction with a denominator of 15 will multiply the top and bottom by 4, and we'll multiply 5 times 12. This means fraction with a denominator of 12 will multiply top and bottom by 5. Our LCM would be 60, since 4 times 15 is 60, as well as 5 times 12. 4 times 4 is 16, plus 5 times 5, which is 25. 16 plus 25 is 41 over 60. We need to make sure 41 over 60 is in simplest form. Since 41 and 60 are relatively prime, we know that Alonzo used 41/60th of a cup of cheese to make the baked ziti. In the next part of this lesson, we'll be talking about a square, which is a quadrilateral with 4 right angles and 4 congruent sides. A quadrilateral is a 4-sided polygon. There are several special types of polygons you may already know, such as the trapezoid, the parallelogram, the kite, the rhombus, the rectangle, and the square. We also have some that are not special, such as figure 1 and figure 2. As long as the figures are polygons, which is defined as a closed plane figure formed by 3 or more line segments intersecting only at vertices. Therefore, we should only have line segments, and this one is not a polygon because this is a curve, it's not a line segment. This is not closed, it's open, and these lines are intersecting at places other than the vertices. And this is not a plane. A plane is a 2-dimensional figure. A square also has 4 right angles. A right angle is an angle that measures 90 degrees. When we see this symbol, it identifies the angles as being right angles. A square also has 4 congruent sides. Congruent, figures having the same shape and size. The symbol for congruence is an equal to sign followed by this squiggly line, which is a similar sign. The equal to means they have to have the same size. This little squiggly line, which means similar, means they have to have the same shape. We'll learn more about this in the second semester. This marking are called tick marks. The tick marks identify the sides as being congruent, meaning they have the same length. The space inside a figure is called the area. If the side length of this particular square is 3 units, that means all the sides are 3 units because the sides of a square are congruent. This also means that the area of this particular square is 9 units squared because we can fit 9 squares inside of it that are 1 by 1 unit. Can we form a square using exactly 12 tiles? Would this be considered a square? This is 2 by 6. In a square, all the sides have to be the same length. So unfortunately, this is not a square. Let's look at another arrangement. Would this be a square? It looks a little bit closer, but this is still 3 and 4. And remember, the sides of the square, they can't be almost the same length. They have to be exactly the same length. So this is not a square either. So why can't we make a square using exactly 12 tiles? And it has something to do with the factors of 12. Factors are numbers we multiply to get a product. The product we're trying to get is 12. So the factors of 12 would be 1 and 12, and that definitely wouldn't make a square. 2 and 6 we noticed didn't make a square, and 3 and 4. And the reason why 12 won't make a square is because 12 is not a perfect square. But numbers like 1, 4, 9, and 16 are perfect squares. Hence why we can make a square out of these numbers. When we see 1 squared, that means it's going to be a 1 by 1 square. And we use the term square because we'll have 1 square. When we see 2 squared, it's going to be a 2 by 2 square. And we use the word square because we'll end up with 4 squares. 3 squared is a 3 by 3 square. And we use the term square because we'll end up with 9 squares. 4 squared would be a 4 by 4 square. And we use the term squared because we'll end up with 16 squares. These are not the only perfect squares. As long as you're multiplying a natural number by itself, you'll end up with a perfect square. Notice this when we were learning our timetables. These numbers in the red are our perfect squares. 2 consecutive perfect squares would be 2 perfect squares that are next to each other, like 1 and 4, 16 and 25, maybe 64 and 81. We measure area in square units, just like you might see the tiles on your floor. The area of a square is the side length squared. Area is equal to S squared, which means side times side. When given one side, we are actually given all the sides. Since area is equal to S squared, we'll substitute 7 in for S. 7 squared means 7 times 7. Therefore, the area is 49 meters squared. So therefore, we'll have 49 squares. The square root of 49 is equal to 7 because 7 times 7, or 7 squared, is equal to 49. When we're looking for the square root of a number, technically we're just trying to find the side length of a square that has 49 square units. Find the side length of a square with an area of 64 yards squared. S is equal to the square root of the area. Since the area is 64, the square root of 64 is 8. Our side length is 8 yards.